The tree of life of human beings. It's fascinating, it's complex, and it's very, very poorly well understood by most people. And this highly controversial series of data is something that I think that is important to synthesize briefly, because it provides yet another expression of this idea of the Woesian tree of life and then encapsulating the Darwinian tree of life that's in the branch of the eukarya. So let's look carefully and do a brief overview of what we know now. And I should preface this by saying that there is a lot of research going on around the world investigating the whole history of the tree of life of the hominids, or the human being lineage. And something that's important about that is that continually, because of the richness of some of the new fossil finds that are being excavated and analyzed, the story of human evolution is going to continue to change. And that's the hallmark of a great scientific theory, is that the theory is established due to rigorous testing and rigorous development by many scientists around the world, but yet it's something that is constantly evolving itself. So the current snapshot of human evolution is the following. A transition took place from a primate-like organism into the earliest of the hominid lineage. And that earliest hominid lineage we call Australopithecus. And Australopithecus is important and well known because of the famous fossil find called Lucy, which was deposited about 3.2 million years ago. And it was a nearly complete skeleton of a female adult Australopithecus. Now, Australopithecus for many years, and Lucy was one of our oldest human ancestry fossil finds. But recently, another group has found another representative that is a transition between the early last common ancestor, which was the primate, into the lineage of the hominids and Australopithecus. And that is called Ardipithecus ramidus. And Ardipithecus ramidus showed us that humans, instead of evolving in an open grassy savanna, actually evolved in the margins of a savanna in a forest. It has to do with the structure of the feet and the structure of the hands. And it also gave us this really important picture that humans have evolved as dramatically from the last common ancestor that was primate as have the chimpanzees themselves. Well, then once we get into the realm of the Australopithecines, then we see that we have many types of fossils, nearly complete skeletons, fragments of teeth, fragments of bones, fragments of vertebrae. But we also had something else that is somewhat unexpected, and that are footprints or trace fossils. So the famous Latolai footprints were an adult Australopithecine and a juvenile Australopithecine that were walking across a very recently deposited ash bed that came from a volcanic eruption. And so as you can see in this image, the two sets of footprints, one juvenile and one adult, walking across this recently cooled ash bed is very well preserved. So we have a lot of information about the Australopithecus lineage. Well, then we move into a time period when traditionally we've had less fossil evidence, but now that's all changing because of recent activity, and that's called the Dark Ages. And in other words, from about 3 million years going to about 2 million years, the amount of fossil evidence was less than we had for some of the later intervals of time. Now, in this Dark Age time period, we had the evolution and the emergence of the first true part of the lineage of Homo. And of course, we're Homo sapiens, and the earliest groups of the Homo sapien species came up at this time period. Now, the first one was called Homo habilis, and it's the tool maker. And at about 2.3 million years before present, we find the remains of an upright, bipedal, very much human-looking type of organism. And it had the capability to make tools. And these tools were crude, yet they were effective. They were able to make sharp points out of rock and be able to use those to clean hides, to cut wood, to do various different types of activities. Well, relatively soon after that, at about 1.8 million years before present, we had the rise of another very important lineage, and that's the Homo erectus. And Homo erectus, as we go through the sequence, each of these steps in the human evolution, we had more sophistication in terms of using tools. We had more sophistication in terms of starting to develop some kind of societal bonds and societal cultural types of interactions. And Homo erectus was very important because it was not only more sophisticated, but it was also a migratory and traveling the earliest of the Homo lineage that actually like to travel a lot. And remarkably, we see that these Homo erectus and some of the other related species, they traveled into Asia, and then eventually they traveled into Europe. But another really important aspect of this is that after they migrated into these places, they did very poorly, and they actually were lost and did not continue to live in either Asia or Europe after they initially migrated in. And the current distribution of human beings in all these continents, it was something that arose relatively recently and not until we had the Homo sapiens arise. Another big question about the Homo erectus and then into the next series of human hominid types of fossils is the question of, well, we see a dramatic increase in the size of our brains. And so we made trade-offs during our evolution going for more brain capacity and less robustness, less largeness, less size, less muscular aspects of our bodies. And that dramatic increase in brain size, getting up to about 3 times what it was originally in Australopithecus. One of the questions has been, well, did that arise as a result of having tools that were starting to be made, and then the supercomputer of our brains needed to be evolved to respond to the capability to actually manipulate and do things with tools? Or was it the opposite? Was it that our brains evolved, and then because of that increased capacity, we could actually start to make tools? And it's the chicken and the egg question, which one came first. So that's a highly controversial area right now that's being studied. But the importance is that by the time we got to Homo erectus at 1.8 million, then we had basically the fundamental capabilities to start migratory patterns and to have this loosely knit kind of cultural and social and tool technology capabilities moving forward from that. Now, one of the next very famous groups of the hominid lineage are the Homo neanderthalensis. And the Neanderthals are famous because, first of all, they were shorter than we are in general, and they were very stocky, they had big bones, they were very musculatured, and they lived in very harsh environments. They lived either on the top or the margins of gigantic ice sheets, especially up in Europe. And so the Neanderthals, they had, again, the next generation, a more sophisticated culture. There's been finds of burial sites within caves, and within those burial sites, pretty sophisticated tools that were intricately carved and put together, as well as some very, very primitive paintings that have been found for that. So the Neanderthals were not so distant from what we're used to in terms of thinking of Homo sapiens. Well, the last generation, of course, was the Homo sapiens. And what's remarkable is that planet Earth has not for very long had only one species of the Homo lineage. There were multiple species interacting throughout time over the last 4.2 million years, and it wasn't until relatively recently that we had only one species. Now, there's good fossil evidence that the Homo sapiens interacted with the Neanderthals, especially in Europe, and some have postulated that they drove the Neanderthals to extinction. Others have been using new DNA technologies to suggest that perhaps there is actually inbreeding between the Neanderthals and the Homo sapiens. So these are all very crucial and highly contested hypotheses right now, which the increasing evidence from the fossil record is providing us with new insights on a regular basis. So the important thing here is that the tree of life of the hominids, going from this Ardipithecus ramidus, which proved that we had divergence away from the chimps and the gorillas very early. So our last common ancestor did not look chimp-like, or at least it's highly unlikely that it did. And then it went into the lineage of the Australopithecines, into the Homo habilis, the Homo erectus, the Neanderthals, and then the Homo sapiens. And it wasn't until just in relatively recent times, over the last 500,000 years, that we've had one species of the Homo lineage that has been distributed around the planet.